Guys, today we will be solving O-Levels Physics paper 21 year 2020. Let's get question 1. Shows figure 1.1 shows the thinking distance and the braking distance for a car being driven along a dry road and along a wet road at the same speed. Part 1. Calculate the total stopping distance for the car on the wet road. As you can see, this is the graph for the dry road and this is the graph for the wet road, which shows that the driver took 18 meters to think about the braking and 16 meters were used by the car to stop. We will simply add both of them and our answer will be 78 meters. Part B. Complete the sentence. The braking distance is the distance traveled between seeing a hazard and pressing the brake pedal. Part B is asking us about the definition of thinking distance. It's practically just seeing the hazard and pressing the brake pedal. Part C, Part 1. Suggest why the thinking distance is the same on the both roads. Answer. Because in both cases, driver takes the same distance to see the hazard and press the brake. Part 2. Explain why the braking distance is larger than the road when the road is wet. Answer. The braking distance depends on the friction between the tire and the road, but the water on the road decreases the friction due to which the car takes more time to brake or stop. Question 2. A student performs an experiment to mark the center of mass on a thin piece of cardboard. These are two holes on the cardboard. Figure 2.1 shows the card and two lines that the student draws on the card. This is the figure. As you can see, the student have made two holes, 1 and 2, and he is going to find the center of gravity using these two. Part 1. Describe a method used to draw these two lines in the correct position on the card. Make clear what extra apparatus is needed. You may draw a diagram if you wish. A diagram is not necessarily needed. Answer. We first hang the cardboard piece from one hole and also hang the pump line with it. When we draw a line at the position of the pump line, then we do the same process with the second hole. Now pump line should be necessarily be included or else you will not get the mark. Part B. The student holds the card loosely between her fingers. The card is virtually resting with its lower edge on the bench as shown in figure 2.2. As you can see, this is showing that the person is holding the card with very small friction and is depending on the bench. The card is slightly tilted as shown in figure 2.3 and then released. As you can see, the person just picks a little bit and then releases it. One. Explain the card falls anti-clockwise when the angle is larger. Answer. When the angle is larger, the center of gravity is on the left side, due to which there is more mass compared to the right side, due to which it falls anti-clockwise. Now you have to clearly describe at what position will it fall. State one change to the card that makes it more stable. Longer base. Question 3. A student suspends a spring from a support. He attaches different loads to the lower end of the spring. For each load attached, he measures the extension of the spring. Figure 3.1 shows the extension load graph obtained. Figure 3.1. As you can see, the figure is showing us that the spring was put load on. Part A. The extension of the spring is directly proportional to the load. State 2 features the graph that shows us. Part 1. The line is straight. As you can see, the line is straight. That means the gradient is constant. Part 2. The line is passing through 0 is to 0 or the origin. As you can see, the graph is starting from this point. It's not starting anywhere from here or here. It's starting from 0 to 0. Part C. The spring is using a simple device known as accelerometer. Figure shown in figure 3.2. The spring is fixed at one point and attached to mass of 5 kg at the other end. The mass rests on a smooth horizontal surface. There is no friction between the mass and the surface. The whole device is placed in a car. The car accelerates and the student notices that the acceleration of the spring is extension of the spring is 3 centimeters. Use figure 3.1 calculate the acceleration of car. Now we will use the graph shown in the previous question and we will see if the mass is 5 kg what will be the force, and according to the graph the force is 4 Newton. And if you use the formula of force, which is mass multiplied by acceleration, we can simply find out the acceleration using this method, and you will get an answer as 0.8 meters per second. Question 4. Glass and iron are both conductors of heat. However, glass is a poor conductor of heat and iron is a good conductor of heat. Part A. Describe using ideas about molecules how the conduction of heat takes place in glass and in iron. You should make it clear why iron is a better conductor of heat. Conduction in glass. Conduction in glass is a process by vibration in the molecules through which the energy passes on and the electrons collide. Conduction in iron. Conduction in iron is also the process by vibration of molecules, but it has more free moving electrons, due to which they are more efficient. Will be our answer. Part B. Figure 4.1 shows an apparatus used to show expansion. The glass flask full of water is heated. A student is surprised when the liquid level X in the glass tube falls for a few seconds before it rises. Suggest why the liquid level falls and why then it rises. Answer. The glass warms before the water and expands first, giving more space for the water to settle, but when the water gains heat and goes to a high level as it has more expanding power. Part 2. Describe how heat is transferred throughout the water in the glass flask. The heat is transferred to water from the flask when then convection takes place and hot water rises as it has less density and the cool water creates convection. Question 5. Part 1. Part A. Use the relation between pressure, force and area to explain why it is harder to cut something with a blunt knife than with a sharp knife. Answer. Pressure is equal to force upon area, and as the area increases in the blunt knife, less pressure is experienced, whereas in sharp knife there is more pressure experienced due to the less area. Part B. Experimental measures on gas pressure were made by Robert Boyle. He showed that pressure 1 multiplied by volume 1 is equal to pressure 2 multiplied by volume 2 are the initial and final pressures of a gas, and volume 1 and volume 2 are the initial and final volumes of the gas. State 1. Part 1. State 2 of quality is that must remain constant when the equation and when this equation is used. Temperature and mass of gas. These qualities should not change. Part 2. Figure 5.1 shows the molecules of gas and the volume of gas is held. Held, yes. The equation suggests that when the volume of gas holds, the pressure doubles. Using idea about molecules, explain why this happens. Answer. As the molecule of gas are frequently moving, due to which they hit walls, but if a container is smaller inside, the molecule will hit walls frequently. Question 6. A dentist uses a plane mirror to see the back of a tooth. Part A. A plane mirror produces an image on an object. Describe the position of the image. Plane mirror produces inverted image, but it has the same distance as the object from the mirror. Part B. Figure 6.1 shows the plane mirror used by dentists to see the point labeled X on the tooth. On figure 6.1, part 1, the mark the position of X, image of X formed by the mirror. Here you go. To draw a ray of light from X to show how the dentist can see the tooth. There you go. C. State one characteristics of image formed by the plane mirror other than its position. Answer: the image is inverted. Question 7. Two isotopes of carbon are carbon 12 and carbon 14. One of these isotopes, carbon 14, undergoes radioactive decay. Part A. Describe what is meant by radioactive decay. Answer: it is a process by which an stable atom nucleus loses energy by radiation. Alpha, beta, and gamma decay have few of its examples. Part B. Carbon 12 has a proton number, atomic number of 6, and a nuclear number, mass number of 12. Complete table 7.1 for the nucleus neutral atom for each of these two isotopes. The table 7.1. Oh wait, no, this is the answer. This is the answer. I just made a table and you can see the answer. Part C. A sample of carbon 14 is contained in a thin aluminum container of thickness 0.2 mm. Radiation from the sample is detected outside the container when the thickness of aluminum is increased to 6 mm. Radiation from the sample is detected outside the container. Part 1. State the type of radiation which is stopped by increasing the thickness of the aluminum. Answer: beta particles. Beta particles are the answer. Part 2. Explain how you know that the sample does not emit all other type of radiations. Aluminum does not emit gamma, as gamma does not pass through the thick container such as 6 mm aluminum. Next, answer two questions from the section answer in the space provided. You only have to answer two questions from the section B, but I will be answering all of them for better understanding. Figure 8.1 shows a limb from a car. It contains two metal filaments. Figure 8.1 part 1. Complete the box to describe the transfer of energy that takes place when lamp is switched on. Electrical energy is converted into heat energy and light energy. Part 2. The efficiency of metal filaments lamp is less than 10%. State what is meant by efficiency. Efficiency is equal to useful output upon total input. Part B. The two filaments are usually connected in parallel to a car battery. A student investigates what happens when the car filaments are connected in series rather than in parallel. He uses the same battery for the investigation. State whether the current and the voltage across each filament and total power produced increase, decrease, or stay the same when the two filaments are connected in series. Current decreases, volume decreases, voltage decreases, and also the power decreases. Part C. Figure 8.2 shows the current voltage graph of the two filaments. As you can see, this is for the one and this is for the second. Part 1. Calculate the total resistance of the two filaments when they are connected in parallel to the voltage of 12 volts. And see, as you remember the formula of resistance, which is voltage upon ohms or current. In case 1, 12 upon 2, when there is 12 volts, as you can see over here, when there are 12 volts, the current is this, whereas in this case, when the voltage is this, the current will be around here. Now if you go further, the total current will be 2.5. As you can see, 0.5 plus 2 will be 2.5, and if you divide 12 by 2.5, there will be 4.8. Next part, the two filaments are made from the same type of metal and have the same length. When uncoiled, they both operate at the same temperature, suggests why one filament has a resistance that is greater than that of the other filament. Answer: because of the difference in the radius of filament. Question D. Figure 8.3 shows a relay used to switch on a car headlamp. As you can see over here, it's showing there is a switch, there is a pivot, there is an iron armature, there is a flexible contact, there is battery and a headlamp. Question asks us, explain why headlamp H lights up when the switch S is closed. Headlight lamp lights up as the coil lights up, and coil becomes magnetized and attracts iron armature and due to the pivot it turns and causes the flexible contact and current contact and current flow in current. As you can notice over here, this is the switch when it's turned on. Look over here, the positive side is over here, current starts flowing from here, goes over here, comes here, goes to the switch. When the switch is turned on, it goes further and goes into the coil, which makes it magnetize. Due to the magnetic field, it attracts the iron armature, and due to the pivot, this part is pushed out and making the flexible contacts come in contact, due to which the current flows and this lamp lights up. Question 9. Ultrasound and X-rays are both used in medical imaging. Part A, Part 1. Define what is meant by ultrasound. Ultrasound has a frequency above 20 kHz or 20,000 Hz, hence cannot be heard by humans. Part 2. Describe what happens to ultrasound waves as they make the boundary between two different materials. Answer: some of the sound waves reflect while the other some is observed by the material. Part 3. Produce the image of an unborn child. An ultrasound emitter and receivers are placed close together on the mother's skin. You can see the pulses are shown here. This is before the radiation was emitted, and this is after. Pulse A is emitted pulse, and pulse B is the first pulse that returns from the unborn child. The average speed of ultrasound in human tissues is 1,500 meters per second. Calculate the distance between the emitter and the child. Now the formula of distance is speed multiplied by time. Speed is 1,500 meters per second multiplied by 0.03 multiplied by 10 multiplied by with the power of -3 upon 2 bracket close. This is the time, and you see over here time is divided by meters per second, due to which we have to do the same over here, and it gives us 0.023 meters. Part 4. The speed of ultrasound in human tissues is close to the speed of sound in water. Suggest approximate values for the speed of sound in gases and solids. Speed in gases 1000 meters per second, speed in solid 2000 meters per second. It's just an approximate value. Question B. Figure 9.2 shows an X-ray image of an hand. An X-ray detector is placed just below the hand. An image of the bones and human tissues on the bones are found formed on a screen by the detector. Now the X-ray emitter is placed above the hand and the X-ray detector is placed below the hands, due to which when the X-rays are going through the hand, the skin is absorbing some of them, due to which it it makes it a little black, a little white. Whereas when the X-rays are meeting with the bones do not allow the X-rays to pass through, due to which no X-ray is passed. But when the X-ray reaches the X-ray detector, it makes the image black. Now, describe what happens to the X-rays to produce the image. Answer: the X-ray passes through the hand, but it does not pass through the bones, and some of the X-ray absorbed by the skin tissues, but the X-rays that reaches back makes the image black. Part 2. The wavelength of X-rays used is 2.0 multiplied by 10 multiplied with the power of -9 meters. The speed of electromagnetic waves is 3.0 multiplied by 10 with the power of 8 meters per second. Calculate the frequency of X-rays. Frequency is equal to V upon X, which will be 3.0 multiplied by 108. Oh, wait. 3.0 multiplied by 10 with the power of 8 upon 2.0 multiplied by 10 with the power of -9. The answer is frequency is equal to 1.5 multiplied by 10 with the power of 17 Hertz. Part 3. Suggest one reason why the X-rays are not used to form an image of an unborn child. X-rays kill cells and also cause cancer, due to which they are not used. Question 10. Figure 10.1 shows a motor lifting a mass. Figure 10.2 shows the part of the circuit diagram of the connection to the motor. Now, as you can see, wait a second. As you can see, this is the motor lifting the mass, whereas this is the circuit. These are the battery and this is the switch. These are the batteries and this is the switch. Now, Part A. The circuit in motor is 1.5 amperes and the voltage supplied to the battery by the battery is 8.0 volts. Part 1. Calculate the current diagram. Complete the circuit diagram in figure 10.2 to show an ammeter and the voltage in the current position. To take these measures while the motor is running. Now you can place your voltmeter just above the motor, or you can also put your voltmeter with the battery. And when it comes to ammeters, it is supposed to be in the circuit. Now, part 2. The motor takes 4.0 seconds to lift the mass. Calculate the electrical energy transferred to the motor in this time. Energy is equal to volts multiplied by amperes multiplied by time, which will be 8 multiplied by 1.5 multiplied by 4, which will be 48 joules. Part 3. The motor lifts the 150 gram mass through a rate of 80 centimeters in the 4.0 seconds. Calculate the gravitational potential energy gained by the mass. Gravitational potential strength G is equal to 10 Newton upon kg. Energy, the formula of energy is M multiplied by G multiplied by H, mass multiplied by gravitational force multiplied by height. Now, which will be 0.15 multiplied by 0.8 multiplied by 10, which will be 1.2 joules. As you can see, the value of mass was given to us in grams, but using it in a formula, we have to convert it into a SI unit, which is kg. Now, gravitational potential energy is 1.2 joules. Part 4. State two reasons why the gravitational potential energy gained by the mass is less than the electrical energy supplied to the motor. Answer 1. Sun is wasted by producing heat generated in wires. Part 2. Answer. Mass has kinetic energy. Question B. Figure 10.3 shows the structure of motor. When the mass reaches the top of its motion, the switch is opened. This disconnects the battery and causes the mass to fall. The coil turns as the mass falls. As the coil turns, a small voltage is produced. Part 1. Explain why the voltage is produced as the coil turns. There is a magnetic field between the permanent magnets of north and south poles, and as the coil turns, the line of the magnetic field induction takes place. Part 2. As the mass falls, a student connects a wire between the point A and P, shown in figure 10.3. He notices that the mass takes a longer time to fall when the wire is connected. The student suggests that this is an example of Lenz's law. State Lenz's law is just when the mass takes longer to fall. Lenz's law states that the direction of electric current, which is induced in a conductor by a charging magnetic field, is such that magnetic field created by the inducted current opposes the initial change in magnetic field. As the coil becomes a magnetic, pole of coil attracts to the opposite pole on. Thank you for watching this. See you next time.